Okay, hello world. So in today's video, we are going to be looking at the algebraic method of finding a resultant. Remember what a resultant vector is? That is the sum of two or more vectors acting together. And the vector could be anything. The vector could be a force. And we can even go as far as defining a resultant force. When we define a resultant force, we are just specifying the type of vector. So from the original definition of resultant vector, if you want to define a resultant force, you go and replace the vector with force. So resultant force would be a sum of two or more forces acting together. Or alternatively, it could be a single force. I'm just going to put this up here. This could be a single force having the same effect as two or more acting together. So these are just the definitions of resultant vector, but we just replace the word vector with force. Okay, so if you want to use the algebraic method, step number one, you need to pick a positive direction. And from the directions that you're going to be having, you're going to replace those directions with positives or negatives, depending on what you chose as your positive direction. And then you are just going to you're going to add the vectors together as the definition of resultant vector suggests. So let us look at the two vectors that we have. We have F1. F1 is 10 newtons. Let us look at the direction. The direction would be west. But when we look at the other vector, we have F2. F2 is 6 newton. Then the direction is east. So we are going to need to pick a positive direction before we add the vectors together. So I am going to take west as positive. So you can use the arrow to indicate that direction, that will be the positive direction. Writing it down just makes it easy so that you do not forget. So our resultant will be equals to F1, resultant, sum of, plus F2. Now, if we want to write our F1, we're going to replace the west with a positive or negative. So this means this will be positive 10 newton, whereby the positive represents west. Even if you choose east as positive, we should all get to the same answer. When I get to the other vector, F2, that would be negative. If west is positive, then the opposite of west will be negative, which is east. So east is negative. So this will be negative 6 newton. So I can come over here and start summing those vectors together. R will be equals to positive 10 plus the other one is negative 6. When we sum those together, we find that R will be equals to positive 4 newton. But wait, what does the positive represent? That is actually direction. So R will actually be 4 newton west. So even if you chose east as positive, we should get to the same concluding statement that the resultant will be 4 newtons west. So even if we were to just throw these tail to head without any measurement, we should still get the correct direction of resultant from the sketch. So we have our F1. I'm going to start with F1. There's F1. My apologies, that is not a straight line. So that is tail to head. And then from the tail of F1, from the head of F1, I'm going to start with the tail of F2. So that will be tail to head. And from the magnitudes, I can see that F2 should be shorter as compared to F1. Remember how we were drawing the resultant yesterday? We drew the resultant from the tail of the first vector drawn to the head of the last vector drawn. So if I were to do that, sketch the vector diagram, sketch not drawn to scale, from the vector diagram sketch, we still obtain the same information about the direction of the resultant. I'm going to keep on revisiting the concept of drawing the resultant because we are going to use it, we're going to need it, in fact, a lot in the section later on. Okay. So we can take another example. The other example, we are having our forces along the vertical direction. It does not matter whether our vectors are along the horizontal direction or along the vertical direction. As long as they are along the same direction, we can add the vectors the same way. Remember step number one is to pick a positive direction. So I am going to take upward as positive. So it means we have positive 2 Newton, we have a positive 5 Newton because both of them are upward, and because that one is pointing in the opposite direction, which is downward, it means downward will be negative. Downward will be negative. So that vector there will be negative 4 Newton. So our resultant, let us see, the resultant R will be equals to positive 2 plus positive 5 plus the positives that I'm writing in between there from the definition of resultant, which is sum of. So plus negative 4, whereby the negative is for the direction of that vector. If you sum them together, you are going to get, let us see, you're going to get positive 3 Newton. So it means that our resultant is 3 Newtons upward. So R will be equals to 3 Newton upwards. Okay, so we can draw these vectors tail to head. So I am just going to start with the 4 Newton. You can start with whichever one. So there's the 4 Newton, and then I drew it from the tail to the head. From its head, I'm going to start with the tail of the 2 Newton. Clearly, the 2 Newton should be shorter than the 4 Newton. So this is 4 Newton. That one there is my 2 Newton. And the 5 Newton should be longer than the 2 vectors that I've already drawn. So that will be my 5 Newton. Okay, remember how we draw the resultant? That is from the tail of the first vector drawn. It does not matter how many vectors you are having. The first vector drawn was the 4 Newton. So the resultant will be from the tail of this vector to the head of the last vector drawn. The vector that I drew last, that was the 5 Newton. So that over there, which is supposed to be straight, that will be my resultant, which is having an upward direction. If anyone has suggestions on what I can use to draw these vectors, I would really appreciate that. Okay, so that will be the resultant. And now, let us look at 2 vectors, 5 Newton and 10 Newton. And at this point, we do not know what the direction of these vectors are. But we can try to figure out what the minimum resultant is going to be or what the maximum resultant is going to be. So let us make a guess. Let us assume that the two vectors are in the same direction. So let us say this is the 5 Newton, and let us say that one there, that is the 10 Newton. By the way, if you like, you can draw these vectors. If you like, you can draw these vectors on top of one another. For example, you can have the 5 Newton, and on top of the 5 Newton, you can have the 10 Newton. Okay, so the long one, that is 10 Newton. The short one, that will be 5 Newton. I'm going to need this sketch at a later stage. Okay. So if we have our vectors pointing in the same direction, let us try to figure out what the resultant is going to be. Remember, before you calculate the resultant, you need to pick a positive direction. So I'm just going to take the westerly direction as positive. So it means that the resultant will be positive 10 plus positive 5. That is positive 15 Newton. So what this means is the resultant vector is actually 15 newtons in the westerly direction. But wait, let us check what the angle between the 5 Newton and the 10 Newton is if they are along the same direction. So if you try to put a protector there and measure, then the line between the two vectors will just be along the thick 0-degree line. So what this means is the angle for this case where they are pointing in the same direction, the angle between the two vectors is 0. Then let us try to find the resultant when the two vectors are in opposite direction. If they're in opposite direction, it does not matter how you place them, whether it's along the vertical or the horizontal, but I'm just going to pick the horizontal. Let us say that the 5 Newton was in the easterly direction, and let us assume that the 10 Newton was in the opposite direction, which is the westerly direction. So I am just going to pick this time around, I am going to take east as positive. If we try to find the resultant will be positive 5 plus, that one is in the west, so it will be negative 10 newtons. The answer will be negative 5. What this means is that our resultant is 5 Newton. That is for the magnitude. Direction will be west. Okay, so if the two vectors are in opposite direction, what do you think the angle between them is going to be? The angle between them, how do you get that angle? So you can take a protractor if you like, or you can just do it by inspection. If we are trying to know what the angle between that line and that line is going to be, and though because these vectors are along the same straight line, it means we are looking at a supplementary angle there. We are looking at a 180-degree angle. So that angle there is 180 degrees. So if we compare the answers that we are having here, if the vectors are in the same direction, and when we say they are in the same direction, we mean that the angle between the vectors is 0. If the angle between the vectors is 0, they're in the same direction, it means the resultant will be large. If we compare the two resultants that we have, this is larger than that one, larger in magnitude. So it means that the resultant vector vector or the resultant force is maximum when, let me just generalize it for all the vectors. So the resultant vector is maximum when the two vectors are in the same direction. It does not matter which two vectors you are taking, as long as they're in the same direction, resultant will be maximum. And the opposite is true. The resultant of two vectors is minimum when the vectors are in opposite directions. So that is the conclusion that we can make. So let us take a quick example. Let us take two vectors. Let us say we have a 2 Newton vector and I'm not drawing this using the tail to head method, by the way, and a 6 Newton vector. So these vectors are forces. So from the diagram that we are having, will the resultant be maximum or will the resultant be minimum? Okay, you guessed it right. Because these vectors, they're in opposite direction. One is west and that one is east. The angle between the two vectors is 180 degrees. It means that the resultant will be minimum. And what is actually interesting is it does not matter how you put the vectors. The point is the resultant, irrespective of how you put the vectors, the resultant vector will be any value between the minimum and the maximum value. Let us just take these two vectors as an example. So if we try to calculate, you can try this on a rough piece of paper. If you try to find the resultant over here, you'll find that the resultant is going to be 4 newtons east, which is actually the minimum that the 2 Newton and the 6 Newton could have. But if they were in the same direction, you had the 2 Newton and then you also had the 6 Newton. In this second diagram, our resultant will be 8 Newton east. So this is the maximum value. So if I were to arrange the two vectors in such a way that this is the 2 Newton, that is, let us say, the 6 Newton. In such a way that the angle is greater than 0 but less than 180, that is the angle between the two vectors. Point is, if I were to try and figure out the resultant, what it is, one way or another, what I would find is the resultant here. The resultant will be between, I'm going to use math language here. So the resultant, let me use intervals. So the resultant R will be a value which is greater or equals to the minimum, which is 4 Newton, but it will be less or equal to 8 Newton. So the resultant of two vectors is always a number between the minimum value which we get when the two vectors are opposite each other and the maximum value which we get when the vectors are along the same direction. The resultant here will be any value from 4 to 8. So what it means is the resultant of these two vectors can never be 3, can never even be 9. It can never even be 8, comma 1. So yes, that's it for today's lesson. In the next video, we are going to look at collinear vectors.